Good day, ladies and gentlemen. Mr. Strassel here. Today we're going to talk about Unit 9, Lesson 2, Activity 2, Part 2. And before you read this, you might go back and review this particular part of Unit 9, Lesson 2, Activity 2. This was done in video number 1. And we did all this, and we did this in video 1. Today we're going to talk about these. There are only two problems we're going to go over, and they're kind of complicated. Not you just going to have you'll have to just pay attention and maybe watch the video a couple times. So before I do these problems, I want to again refresh your memory about sine of x and the inverse of sine of x. Okay, I got this sine of x, and this is the unit circle approach. This is the unit circle approach, and we've been using the unit circle approach a bunch. So this is using the unit circle. And we know that the sine of x is only, the inverse of sine is only defined when we restrict the sine, when we restrict the domain of sine from negative pi over 2 to pi over 2. So when I restrict the domain of sine and I only go from negative pi over 2 to pi over 2, that makes sine a one-to-one function, and therefore I can talk about this. And I notice here that the range of sine is certainly and is always between this value right here. This y value is -1. This x value is 1. So my sine is going to go from -1 to 1, the output. So the range is from -1 to 1, and the domain is from negative pi over 2 to pi over 2. That allows me to talk about the inverse sine. And what is the domain of the inverse? The domain becomes the range. The range becomes the domain. So this domain becomes the range. This is going to be important for later on today. And the range becomes the domain. Okay? This is just a review of sine and inverse sine. In like manner, to talk about inverse cosine, what do I have to do? Well, I have to look at cosine. Again, I'm doing the unit circle approach here to this. What do I have to do? I restricted the domain of cosine to be between 0 and pi. Between 0 and pi. The range is still, note that the range, this point right here, is 1, 0. We're talking about x values now, -1, 0. So therefore, the range of cosine is going to be between -1 and 1. We restrict the domain from 0 to pi so that I can talk about this guy right here, inverse cosine. And as we did before, as we do on all inverse functions, the domain of the original becomes the range, and the range of the original becomes the domain of the inverse. Okay, so it's important to know, this is the part that we're going to use later on today. The domain of inverse cosine is -1 to 1. The range of inverse cosine is between 0 and pi. Has to be. Those are the only outputs of this guy right here. The only outputs of inverse sine are going to be between negative pi over 2 and pi over 2. So I think that gives us enough information to start on our problem. Okay, so now we're going to talk about, we're going to consider an angle such that this angle B is between pi and 3/2 pi. And the sine of B is equal to E. The first thing I'm going to do is do a graphical representation of this equation right here of sine of B is equal to E, where B is between pi and 3/2 pi. And we can see right here that B is the angle. B is the angle. B is an angle. B is an angle. Okay. And it's an angle between pi and 3/2 pi. So I'm going to, you tell me when to stop. Okay, I'm going to go angle. I'm going to take that terminal side and I'm going to keep moving it. Do I stop there? No. Do I keep going? Yeah, because I have to go between pi and 3/2 pi. So I'm going to go about right there. And that's an angle. And I notice that this angle right here is pi. And I'm going to go all the way here. This angle here is pi all the way. And then this is 3/2 pi. Now I have an angle that's between pi and 3/2 pi. And I want that in this angle right here. I'm going to label that angle B because that's how I denoted it. Sine of B is E. Now, what is E? E is a Y value. And I'm going to put that rascal on there. It is the Y value. We don't care about the X value, but this is my E right there. Okay, the first thing we want to do is to give a lower and upper bound for E. Well, as we saw in the first part of this video, the sine values go, we're talking about Y values, because that's what the sine is, they go from -1 to 1. Don't care about the X values. The sine goes from -1 to 1. But since B, since this angle right here, grab hold of that rascal, since that angle right there is between pi and 3/2 pi, E is going to have to be a negative number. So, and it's going to have to be greater than -1. So here's my lower bound. It's got to be greater than -1, but hello neighbor, it's also going to be less than 0 because, sorry, this is E. E is between -1 and 0. So that's my lower and upper bound, upper bound on E, because E is between -1 and 0 right here. This is Y is equal to 0. Here you go. Why doesn't inverse sine equal B? Well, I'm talking about the range of inverse sine. The range of inverse sine, if I go back to this slide right here, inverse sine, the range of inverse sine has to be between -pi/2 and pi/2. Has to be, because of the way that I have structured the inverse sine, the way that I have limited the domain of sine. So there's no way that can equal B. This does not equal B, since B is not in the range of inverse sine. And that's simply easy enough. B is not B, because B, where is B? Well, this B here is between pi and 3/2 pi, which is not -pi/2 to pi/2. So B is not in the range of inverse sine. Inverse sine has got to be between -pi/2 and pi/2. So what I want then, and this is a bit of a question that's hard to determine what I'm asking here. I want an expression for inverse sine of E. I want to evaluate with respect to our problem, what is inverse sine of E? If it's not equal to B, what is it in terms of B? Well, here's what we're going to do. Let me get this guy out of here for a minute, because what we want is we want an angle that's between -pi/2 and pi/2. We want an angle between -pi/2 and pi/2 that has the same output of E. Well, but it has to be between. So let's do a line here. You tell me. That's between -pi/2 and pi/2. But what angle do I want? Oh, I want that angle right there, because that angle, the terminal point of that angle, yes, you know, the terminal point of that angle is also E. So what I want to know is, what is this angle right here? What is this angle K? Because this I know, ladies and gentlemen, that the sine of K, and now K is between -pi/2 and pi/2, because it's right here. The sine of k, ladies and gentlemen, is equal to the sine of b, because they both equal e. But what I want is this angle k in terms of b. Hard to think about. We can, hey, right away, if not for anything else, we can just let that equal k. Because we know that the sine of k is equal to e. We do know that. But what I want to do is I want to go one step further and say, what is k in terms of b? Can I put k in terms of b? Well, think about this for a moment. Let's just for giggles, let b be, I don't know, 220 degrees. And I like to do degrees. It's easier for human beings to think about degrees. Now do I have an angle between, well, greater than 180 and less than 270. If b were 220, what would k be? Let's see here, 180. Oh, your bet. K would be negative 40. This is just one way to do this problem. So how do I get k then, this negative 40, in terms of 220? True or false? Isn't 180 minus 220 equal to negative 40? It is. It is indeed. And the way to think about that, another way to think about that, if I had this 180 degrees right here, if I took 180 degrees and I subtracted from it, from 180, 220, this whole angle, whoop, where would I get? You bet. I would get this negative 40 right here. But what we want to do, we don't know that b is 220. This was just an arbitrary instant to help you understand. What we want, true or false, isn't k, in terms of b, isn't k equal to this? 180 minus our angle b. It is indeed. It is true. And if I wanted to use radian measures, k is simply going to be pi minus b. So that's an expression for inverse, and this is going to equal inverse sine of e. This is an identity that we're going to talk about in Unit 10, and this is the identity that we can use. If I have any angle, and I can call it b if you want, that's the same as this, the sine of pi minus b. That's an identity. We'll talk more about that, and that's what this activity was, to try to start you to think about this particular identity. We'll look at this identity in Unit 10. Okay? I will tell you, ladies and gentlemen, this is a tough one. This little rascal is tough. You've got to know this slide. You have to know these properties. And then you have to just be very careful and deliberate about graphing B, graphing E. I think you can come up with the bounds of E. I think you can tell me why it doesn't equal B. This part here, I think, might be a little bit tricky. But if you use this identity, which we're going to talk more of in Unit 10, you can go right to the correct answer. Okay. Our last problem here, which we only did 2 problems, is this number 5. Okay? For the cosine of theta, such that b, an angle, is between negative pi over 2 and 0, where cosine of b is d. The first thing I'm going to do, as I did before, is I want to do a representation of this equation on the unit circle. Again, we're doing the unit circle approach. So I want an angle right here. Keep in mind, that's between negative pi over 2 and 0. So let's sketch that angle right here. Okay, here's the angle. Here's negative pi over 2. I want to be between negative pi and 0. Oh, that's greater than 0. I'm talking about angles. That's great. And right here, okay, we'll just put that rascal right there. And that angle, ladies and gentlemen, I'm going to let that angle right here be B. And I know this angle right here is negative pi over 2. And all the way up here to, well, 0. I just wanted, pardon me, I just wanted that rascal between negative pi over 2 and 0, and this is the 0 angle right here. Okay? Right here. So what I want, and now the cosine of b is equal to d. The cosine is x values on the unit circle, so this guy right here, that's d. This is very abstract because we're not using numbers. So that's the graphical representation of this statement right here. Cosine of b is equal to d, and b is indeed between negative pi over 2 and 0. So I want a lower and an upper bound on d. Well, what do the cosine values give me? They give me x values that go from negative 1 to 1. But this d is over here. It's in quadrant 4. So therefore, I know that d has to be greater than 0, and it's going to be less than 1. Right? I think you can come up with this. I really believe that you can. I have faith in you that you can come up with that. I think you can come up with the bounds of d. And why isn't the inverse cosine of d equal to b? Well, b is between negative pi over 2. That can't be equal to b because if I look back here, what is the range of inverse cosine? The range is between 0 and pi. So all of the outputs of inverse cosine have to be between 0 and pi. So simple reason why this is not true, since b is not in this interval 0. It's not in the range. Not in range of inverse cosine. Simple. So now I want an expression for inverse cosine of b. If it doesn't equal b, what the world does it equal? So this is what I want. What does this equal? Give me an expression for inverse cosine of d. Well, d is an x value. The angle has to be between 0 and pi. So you tell me. I'm going to do a different color here. Let's do, I don't know, let's do green. Let's do a green angle. Okay? So now you tell me, where am I going to stop this angle at such that it has an output of d? About right there. Because now I know, in like manner, this terminal point is d. Let's call this angle whatever. Let's call this angle right here. Let's put this one in green. Let's call this k again. And I do know this, that the cosine of k is equal to the cosine of b, which they both are equal to d. But what is this expression then in terms of d? In terms of b? Well, this one is a bit, I think, a little bit easier. If b is negative, I think this is simply just negative b. Because if b is negative, and it is, negative b would be positive, and then this guy right here, this is going to be negative b. And here's my other little identity that I know. Because what do I know? I know that this is equal to cosine of negative b is equal to d. And the identity that this activity was to lead you to is this right here. the cosine of negative b is equal to the cosine of b. Interesting. True enough, exactly a 20-minute video. Kind of tough. You're going to have to think about this, and that's okay. See you soon. Godspeed.